Listening section directions. This test measures your ability to understand conversations and lectures in English. The listening section is divided into two separate timed parts. You will hear each conversation or lecture only one time. After each conversation or lecture, you will answer some questions on it. The questions typically ask about the main idea and supporting details. Some questions ask about a speaker's purpose or attitude. Answer the questions based on what is stated or implied by the speakers. You may take notes while you listen. You may use your notes to help you answer the questions. Notes will not be scored. In some questions, you will see this icon. This means that you will hear, but not see. Part of the question. Some of the questions have special directions. These directions appear in a gray box on the screen. Most questions are worth 1 point. If a question is worth more than 1 point, it will have special directions that indicate how many points you can receive. You must answer each question. After you answer, click on Next, then click on OK to confirm your answer and go on to the next question. After you click on OK, you cannot return to previous questions. In an actual test or during this practice test, a clock at the top of the screen will show you how much time is remaining. The clock will not count down while you are listening. The clock will count down only while you are answering questions. Click on Continue at any time to dismiss these directions.
Listen to a conversation between a university student and a professor in the professor's office. Good morning, Miss Rosencrantz. You're here to discuss your essay? What's the problem? Is your grade too high?
Yes, sir. I mean, no. My grade's not too high. I was just, wondering. I got a B minus, and I just want to ask why. I worked really hard on it, and I thought I'd get a higher grade.
I understand, and I know you worked hard on it. I could tell when I read it that you put a lot of effort into it. Sloth is a problem for some students, but not for you. Unfortunately, hard work doesn't always translate into a high mark. But remember, a B is a pretty good grade, no?
I know it is, but I get mostly B pluses and A's. So, could you please tell me what's wrong with it and how I can improve for next time?
Absolutely. Do you have the essay with you? Let me see. Well, first of all, it's creative and well written. Grammatically. There aren't many mistakes. Your thesis sentence is clearly stated, and it's in the first paragraph. Good, good. I think your greatest weakness is structure. You need to make sure that your supporting paragraphs reinforce your thesis.
Yes, I know. I tried to outline it before I wrote and then, follow the outline as I wrote it, but it got kind of hard to stick with the outline.
An outline is an excellent tool. The trouble with outlines sometimes is that as you write, your ideas change. Something comes to you that you didn't think of when you made your outline, or you get busy writing and find you've strayed from the outline structure. So you need to be careful not to follow your outline too rigidly. It's only a guide.
Yeah, I found that out in the third paragraph, because I wanted to add some of the stuff we learned about the Renaissance. So then I went back and changed the outline, and it was hard to figure out how to include all that.
That confusion shows in your paper. Remember that each paragraph, needs to have a topic sentence, then other sentences that support it. In your third and fourth paragraphs, this doesn't seem to be the case. Here, take a look.
Oh, I see. The topic sentence mentioned changes in art, and then I started writing about changes in religion and science.
Yes, it would have been stronger to treat each of these topics with a separate paragraph. Because you strayed off track in the middle paragraphs, it took some of the punch away from your conclusion. You want to end with a bang, not a whimper. Another thing that lowered your mark was your bibliography section. It doesn't follow the format on the handout I gave you. Your references should be in the order they are cited in the essay. Here you list a reference that appears on page 3 before you list the one you cited on page 2.
Oh yeah, shoot. Sorry about that.
You don't need to apologize, just learn from your mistakes and do it correctly next time.
Yes, sir. Thank you for your help.
I'll tell you what, Miss Rosencrantz, I wish more students were like you. You're the only one in a class of 30 that cared enough to meet with me and challenge your grade. Congratulations. Just because you had the fortitude to do that, I'm going to change your mark from a B- to a B+.
Really? Oh, thank you, Professor Amons. Really? Wow, that's great.
What is the main topic of Ms. Rosencrantz's meeting with Professor Amons? According to Professor Amons, what is Ms. Rosencrantz's greatest weakness in writing? Why does Ms. Rosencrantz mention that she got mostly B+S and As in other classes? What is the professor's attitude towards students' requests for feedback? Why does Professor Amons raise the issue of the bibliography section after discussing weaknesses in Ms. Rosencrantz's structure?
Listen to part of a lecture in a psychology class.
We've been talking about animal cognition, the study of animal intelligence. Now, much of the research in this area is motivated by the search for animal analogs, or parallels to human cognitive processes. And one of the processes we've been investigating is metacognition. What is metacognition? Well, it's being aware of what one knows or feels, having an awareness of one's state of mind, and making decisions about behavior based on what one knows. Researchers have long been interested in whether animals possess this capability, but couldn't test it, because animals aren't able to report their feelings. But recently, one group of researchers found a way to solve this problem. They did studies with monkeys and dolphins that provide evidence that these animals have the ability to feel uncertainty, to feel unsure about something and, well, to know that they're uncertain. So, how could these researchers figure out if an animal feels uncertainty? Well, it began with a study one of them did on a dolphin who'd been trained to recognize a particular high-pitched tone. The dolphin was taught to press one of two paddles, depending on whether it heard the high tone or one that was lower. Food was the reward for a correct response. But if the wrong paddle was pressed, the dolphin had to wait several seconds before it could try again. The task varied in difficulty according to the pitch of the second tone. The closer it came in pitch to the first one, the harder it became for the dolphin to correctly identify it as low. And the researcher noted that the dolphin was quite eager to press the paddle when it was sure of the answer, but exhibited hesitation during difficult trials. Next, the researcher introduced a third option, a third paddle that would initiate a new trial, giving the dolphin the choice of passing on difficult trials. Once the dolphin figured out the result of pressing this new paddle, it did choose it frequently when the trial was difficult. The researcher took that as an indication that the animal wanted to pass because it didn't know the answer, and knew it didn't know. But there was a problem. Other researchers protested that the opt-out response was simply a learned or conditioned response. You remember Intro to Psychology, right? In other words, by pressing the pass paddle, the dolphin avoided having to wait and hastened the possibility of a food reward by moving directly to the next trial. So the experiment didn't necessarily indicate that the dolphin had knowledge of its own uncertainty, just that it wanted to avoid negative consequences. So more recently, our researcher and his colleagues devised a new study, this time using monkeys. In this experiment, the monkeys had to identify certain patterns displayed on a computer screen. These patterns were analogous to the tones used in the dolphin study. One type of pattern was of a specific density and was to be classified as dense, while a second type of pattern could vary in density, but was always less dense than the first one. And the monkey's task was to identify this second type as sparse. So, the denser this second type of pattern was, the more difficult the task became. And, as in the previous study, the monkeys were given a third choice that would allow them to pass on to a new trial. But, unlike in the dolphin experiment, the monkeys had to complete 4 trials before they got any feedback. They didn't know if they'd responded correctly or incorrectly after each trial because there was no reward or punishment. At the end of 4 trials, feedback was given. The monkeys received a food reward for each correct response and a timeout during which a buzzer was sounded for each incorrect response. But the monkeys had no way to tell which reward or punishment was associated with which response. And they didn't get either reward or punishment for choosing the pass option, the uncertainty response. But nevertheless, they still chose this option in the appropriate circumstances, when the trial was particularly difficult. And this is evidence that it wasn't simply a conditioned response, because that response didn't guarantee a faster reward. So, what does all this tell us about animal consciousness or animals' awareness of themselves and their state of mind? Can we really know what's going on in the minds of animals? No, of course not. But exploring the metacognitive capacity of animals could become an important criterion in highlighting the similarities and differences between human and animal minds.
What is the main topic of the lecture? According to the lecture, what specific behavior indicates an animal might be aware of its uncertainty? Why does the lecturer describe the dolphin study first? What is the lecturer's attitude towards the possibility of animal metacognition? Why does the lecturer discuss the monkey study after the dolphin study?
Listen again to part of the lecture, then answer the question.
Other researchers protested that the opt-out response was simply a learned or conditioned response. You remember Intro to Psychology, right?
Why does the professor say this?
You remember Intro to Psychology, right?
Listen to part of a lecture in a paleontology class.
As we've discussed, birds are apparently descendants of dinosaurs and share many commonalities with some dinosaur species, like feathers and maybe even flight, and of course egg-laying. Okay, so many paleontologists, myself included, have wondered about other similarities between dinosaurs and birds. Since adult dinosaur fossils have sometimes been discovered near or on top of nests, we've been looking into dinosaur parenting behavior.
Parenting behavior? Well, that sounds so gentle and caring, but dinosaurs were ferocious reptiles, and reptiles don't take care of their young, do they?
Well, some reptiles incubate their eggs. Crocodiles do. And as for popular attitudes towards dinosaurs, well, take the oviraptor, for instance. In the 1920s, a paleontologist discovered the fossil remains of a small dinosaur near a nest containing eggs. He assumed the dinosaur was stealing the eggs, so he named it oviraptor. That means egg thief in Latin, which fueled the generally negative public image of such dinosaurs. But by the 1990s, other experts had convincingly made the case that, instead of robbing the nest, the oviraptor was probably taking care of the eggs. You see, dinosaurs' closest living relatives, birds and crocodiles, display nesting behavior, and dinosaur fossils have been found in postures that we now believe to indicate brooding behavior, and that is, sitting on the eggs until they hatch. So we're curious about the type of care dinosaurs gave to their young, and we'd like to figure out which dinosaur parent, the male or the female, gave the care.
Shouldn't the behavior of crocodiles and birds give us some clues then?
Well, with crocodiles, it's the female who guards the nest, and with birds, it depends on the species. It can be the male or the female that takes care of the eggs, or both. In over 90% of all bird species, both parents take care of the eggs and the young birds.
But sometimes it's just the male?
Well, exclusive care by the male parent is much less common, but it does occur. Now, for animals other than birds, the care of young by both parents is pretty unusual in the animal kingdom. Males contribute to parental care in fewer than 5% of all mammalian species. It's even less frequent among reptiles, and exclusive care by the male is very rare. So researchers have wondered about the evolution of male parenting behavior in birds for quite some time. And now there's research showing that for some of the bird's dinosaur relatives, it's likely that the male parent was also in charge of taking care of the eggs.
How did they figure that out?
Well, first they looked at clutch volume. That's the number of eggs in the nest of crocodiles, birds, and 3 types of dinosaurs, including oviraptors, that are thought to be closely related to the dinosaur ancestors of birds. So when researchers examined fossilized remains of nests, they found that the dinosaurs had larger clutch volumes, more eggs in the nest, that is, than most of the crocodiles and birds that were studied. But, and this is important, their clutch volumes matched those of birds that have only male parental care. You see, bird species in which only the males take care of the nest tend to have the largest clutches of eggs.
So what's the connection between bird and dinosaur behavior?
Well, researchers now believe, because of this study, that the male parenting behavior of these birds might have its origins in the behavior of dinosaurs.
Based only on evidence of clutch volume size? The number of eggs?
No, there's more. They also examined the fossilized bones of those 3 types of dinosaurs that were found on or near nests to determine their sex. You see, adult female birds during egg production produce a layer of spongy bone tissue inside certain long bones. And so did female dinosaurs of the kinds that were investigated. This spongy tissue serves as a source of calcium for eggshell formation. But when the dinosaur fossils were examined, there were no spongy bone deposits.
Meaning that those dinosaurs on the nests were probably adult males who wouldn't have needed calcium for making eggshells.
Exactly. And then there's this. Birds like the kiwi, the ostrich, and the emu. They share certain physical characteristics with these dinosaurs, and interestingly, they also show a consistent pattern of nest care by the male.
What is the main argument the professor presents for suggesting dinosaurs might have exhibited parental care? According to the professor, what did the presence of spongy bone tissue in adult dinosaurs indicate? Why does the professor compare clutch volume across dinosaurs, birds, and crocodiles? The professor's tone towards the possibility of dinosaur parental care is why does the professor discuss crocodile parental behavior before bird behavior? If humans also share some dinosaurs' clutch volume patterns, what potential explanation does this offer?
Listen to a conversation between a student and his art history professor.
How was the museum?
Great. I hadn't been there for a few years.
Did you enjoy the Van Gogh painting?
That's the thing. Looks like I have to change my topic.
We're getting close to the deadline. You were writing about the theme of night in the paintings of Vincent van Gogh? It's a wonderful topic.
I know. People don't usually think of Van Gogh as an artist of nocturnal themes. They think of brightness, sunshine, all that yellow and orange.
You're right, of course, about the intense light associated with his daytime paintings. But his night paintings don't exactly lack brightness.
That's the paradox that I really like. The paradox of painting a nighttime scene using so much color and light. So I was planning to focus mostly on his painting, Starry Night.
But?
When I went to the museum to look at the actual painting, like you told me to, it wasn't there.
Really? Isn't it part of the permanent collection?
Yes, but it's on loan right now to a museum in Europe.
Ah, I see. Well, I am strict about having students write about paintings they can observe firsthand.
Well, I found another painting I could study instead.
Okay.
I read that there are 2 paintings called Starry Night. The first one was done by the French realist painter Millet. It may have been the inspiration for Van Gogh's painting. Millet's painting is located near my family's house in Connecticut, and I'm going there this weekend and could study it then. I made sure it's not out on loan.
Well, that definitely would work then. Van Gogh copied many of Millet's compositions. We know that he really admired Millet's work. And a lot of us think Van Gogh saw this particular painting by Millet in Paris in the late 1700s.
Yeah, although Millet was a realist painter and Van Gogh a post-impressionist, the 2 paintings still share lots of features, not just the name. The most striking shared feature has got to be the amazing light effects. I'm excited to go see it. But one other thing.
Uh-huh.
I was thinking about getting a head start on my next assignment while I'm at the gallery in Connecticut. The assignment on miniatures. They have a lot of miniature portraits of children as part of their permanent collection.
American miniatures?
Yeah. So I figured I could also get started on that essay, study a few while I'm there. I'd focus on the meaning of the objects that some of the children are holding. Some are holding flowers, one child has a rattle, another a toy violin.
Well, that would be fine. Of those objects, we call them attributes. The attribute chosen to be included in a particular miniature was often meant to communicate parents' hopes and dreams for their child. So I think you'll learn a lot about how people viewed children at the time the miniature paintings were done.
What is the main topic of discussion between the student and the art history professor? According to the conversation, who is currently borrowing Van Gogh's painting, Starry Night? What does the professor mean when he says, I am strict about having students write about paintings they can observe firsthand? What can be inferred about the student's attitude towards studying Millet's painting instead of Van Gogh's Starry Night? Why does the professor mention the French realist painter Millet and the painting near the student's family house?
Listen to part of a lecture in an astronomy class.
There's been a lot of talk recently about life on Mars, at the level of microorganisms anyway, mainly because of a few important discoveries and inventions. For example, one major discovery was that at one point water was present on Mars. How do we know? Well, in 2004, an exploration robot discovered jarosite there. Jarosite is a yellowish-brown mineral with a crystalline structure that's also found on Earth. It contains iron, potassium, and hydroxide. The interesting thing is that on Earth, at least, it needs highly acidic water to form. So we've got water, or had it at one point. And since most planetary scientists believe that water is essential to life, the presence of jarosite means that one prerequisite for life was once present on Mars. But there's another thing about jarosite. One step in its formation on Earth involves microorganisms. They actually speed up the formation of jarosite dramatically. Now, theoretically, it is possible for jarosite to form without the help of biological life forms, but we don't really know for sure if this happens because every corner of Earth has some form of biological life. But jarosite on Earth incorporates all kinds of microorganisms into its crystalline structure. So it's possible that if the jarosite on Mars was also formed with the help of microorganisms, we might be able to detect remnants of them in the samples we find. And we have instruments now that will enable us to try to do this. For example, there's a new instrument called the Microfabricated Organic Analyzer, or MOA. The Organic Analyzer is an amazing tool. It will be able to collect soil samples and analyze them right there on Mars. Pure, untouched samples. It will let us eliminate the risk we would take of contaminating the samples if they were brought back to Earth. And what they'll look for specifically in the soil is amino acids. Amino acids, as you may know, are the building blocks of proteins. In fact, there are 20 standard amino acids involved in making proteins, and lots more that aren't. And here's the important thing. Amino acids are what we call handed. They can exist in two forms, which are mirror images of each other, like hands. Right and left hands have the same number of fingers in the same order plus one thumb. But right and left hands are not the same, they're mirror images. Well, like hands, amino acids can be right or left-handed. And the 20 that make up the proteins on Earth are all left-handed. Now, one reason the MOA, the Organic Analyzer, is so impressive is that it tests not just for the presence of amino acids, but also for the handedness of amino acids. If amino acids are found, it would be especially interesting if they show a prevalence of one type of handedness, either left, like amino acids on Earth, or right. See, other physical processes in space, processes that don't involve living organisms, can create amino acids. But the ones synthesized through abiotic processes, which is to say not involving microorganisms, occur in equal numbers of right and left-handed. So, a prevalence of left-handed amino acids would indicate they were biological in origin, which would be amazing. A prevalence of right-handed ones, well, That would be really amazing, because the organisms that created them would be unlike anything we have on Earth, which produce only left-handed ones.
What is the main topic of the lecture? According to the lecture, what is jarosite, and why is its presence significant on Mars? What does the professor mean when he says this? But jarosite on Earth incorporates all kinds of microorganisms into its crystalline structure. Which of the following statements about Turner is most likely to be accepted by new Western historians? What can be inferred about the professor's attitude towards the microfabricated organic analyzer (MOA)? Why does the professor mention the concept of handedness in amino acids?